Hi team, welcome to Wiggins Maths. In this video we're going to be looking at problems involving differentiating parametric equations. Okay, so let's go for it. The first question I wanted to look at here is part A. It's a very common exam question where you're asked to find the coordinates of where it crosses the axes, the y-axis and the x-axis. So let's have a look at this one to begin with. So we know what it means to cut the coordinate axis. That is, it will cut through the y-axis when x is 0. So we need to find the value of t so that x equals 0. So we can set 2t plus 1 equal to 0. So t must be negative 1/2. And then we can substitute our value of t into the expression for y. And that tells us, therefore, that we're going to be cutting the y-axis at the coordinate 0, negative 3/4. Okay, so what about when it cuts the x-axis? Well, that occurs when y is equal to 0. So that is t squared subtract 1 is equal to 0. So t squared is equal to 1. So t is equal to plus or minus 1. So we're going to get two sets of coordinates this time. So let's deal with t is equal to positive 1 first. So we know that it's going to cut the x-axis at 3, 0. And then what about if t was negative 1? So that is going to be negative 1. So we're going to be cutting the coordinate axis at negative 1, 0 as well. So that's 0, negative 3/4, 3, 0, and negative 1, 0. I thought that was a useful thing to go through. Okay, on to the main event, differentiating parametrics. Now, we can find dy by dx by differentiating y with respect to t and then dividing it by x with respect to t. So if you imagine this was like a normal set of fractions, you know, we can divide fractions by multiplying by the reciprocal, which means the two dt's will cancel each other out, leaving us with dy by dx, which is exactly what we want. So let's start off with dx by dt, and that is just 2. And then dy by dt, and that is 2t. So that therefore tells us that dy by dx is dy by dt divided by dx by dt, which is just t. Now we have to be a little bit careful. Sometimes it will sneakily put something like this in. So we want our answer in terms of x. So we need to then make t the subject in this expression here, in this equation. So x subtract 1 over 2 is equal to t. Therefore, dy by dx is equal to x subtract 1 over 2. Now, normally it will say in terms of t, but I thought I'd point out a problem where it doesn't do that. Right, so what else are we asked to do with differentiation? Okay, so here we have a problem. We've been asked to differentiate it, slightly more complicated here, and we've been asked to find the equation of the tangent. That skill doesn't change, it's still the same approach. So let's differentiate it first. So dx by dt. Now tan squared, we're going to have to use the chain rule. So if imagine that u is tan t, so therefore we've got u squared. If you differentiate u squared, you're going to get 2u, and then we need to do du as well using the chain rule. So we're going to get 2 tan t, and then the differential of tan t in the formula book is sec squared t. Lovely. And then dy by dt, thankfully a little bit nicer. It's just negative sine t, isn't it? Okay, so that means that dy by dx is equal to negative sine t over 2 tan t sec squared t. Now it does say find an expression in terms of t, and we have done that. But from experience, the question's going to be a little bit more prescriptive than that and tell us exactly what form it would like it in. So we're just going to tidy it up a little bit using our knowledge of trigonometry. So tan t, it's 1 over tan t, isn't it? So it's going to be cot. So we've got negative sine t, let's take that half, cot t, and then 1 over sec squared is cos squared t. It's a little bit tidier, but we can still tidy it up even further. So negative a half sine t, cot is cos t over sine t, cos squared, and then the sines will cancel each other out, and that will finally leave us with negative 1/2 cos cubed t. So just showing you that we can actually simplify this expression so we end up with just one trig term. It's a little bit nicer. Okay, so part B is find the equation of the tangent to the curve when t is pi over 4. Now, the rules still apply. In order to find the equation of a tangent, we need the x-coordinate, we need the y-coordinate, and we need the gradient. If we can find those three things, we can find the equation of the tangent. So, when t is pi over 4, x is going to be tan pi over 4 squared. Tan pi over 4 squared is just 1. And then the y-coordinate, cos pi over 4. Cos pi over 4 is root 2 over 2. And m, the gradient, well, that was the point of differentiating, wasn't it? So dy by dx was negative 1/2 cos cubed t, and we want to work out what it is when t is pi over 4. So our calculator will tell us that is in fact negative root 2 over 8, and that is the gradient of the tangent, which is exactly what we want. So now we're going to substitute that into our formula, or I could substitute it into y equals mx plus c and work out what c is, but I certainly prefer this approach. I feel it's a little bit quicker. So we've got y subtract root 2 over 2 equals negative root 2 over 8 x take 1. That's a reasonable way of leaving it. However, I just want to tidy it up. I'm going to multiply everything by 8. Question will normally say leave your answer in the form y equals mx plus c, or ay plus bx plus c equals 0. So that's going to be negative root 2x, add root 2. So I'm going to leave my answer like this. Lovely. Okay, example 3. Again, step 1, differentiate it. Step 2, equation of the normal this time. So let's go for that. So dx by dt, again using the chain rule, imagine that's u squared, becomes 2u du. So that's 2 sine t, and then if you differentiate sine you get cos. And then dy by dt is 2 cos 2t, again using that chain rule. So dy by dx is going to be 2 cos 2t over 2 sine t cos t. That's okay to leave it like that. However, I recognise 2 sine t cos t as sine 2t. So actually, this does actually simplify to 2 cot 2t. As I say, this format is okay. It's fine. It does the job. So, part B, find the equation of the normal. So again, we need the x-coordinate, we need the y-coordinate, and we need the gradient. So when t is pi over 6, x is sine pi over 6. So I'm going to change that into degrees. So sine 30, which is a half, and then square it, which is a quarter. And then we want sine pi over 3. So that is sine 60 in degrees, which is root 3 over 2. And then the gradient of the normal. So dy by dx we had as 2 cot 2t, or the other expression that we left it in, and we're going to substitute in t as pi over 6. And that will give us, if I type it into my calculator, 2 root 3 over 3. Now remember, that is the gradient of the tangent. So of the normal, it's going to be the negative reciprocal of that. And then we can chuck it into our formula like we have done before. So y subtract y1, m x subtract x1. So y subtract root 3 over 2 equals negative 3 over 2 root 3, x subtract a quarter. Again, that's an okay way of leaving it. I don't like the third on the bottom here, so I'm going to multiply 3 by 2 root 3. So 2 root 3 y subtract 3 equals negative 3x, add 3 quarters. And then again, just to tidy this up, to finish it in a format that I think is quite useful, it's going to be subtract 15 quarters equals 0. Okay, final example here. So this time again, differentiate it and then find the values of t for where it's a turning point, i.e. dy by dx equals 0. Okay, so dx by dt is negative sine t. dy by dt is 2 cos 2t. So dy by dx is 2 cos 2t over negative sine t. Remember, I can't turn this into cot because the inputs are different. This input is 2t, this input is 1t. We can't do that. Okay, so find the values of t for when dy by dx equals 0. Now dy by dx was 2 cos 2t over negative sine t. Set that equal to 0. Now if we have a fraction we want it equals 0, it's just the numerator that we want to be 0. So that's telling us that we're trying to solve this trig equation. Notice the input is 2t, so I'm just going to make a note up here that I'm actually looking between 0 and 4 pi, just so I don't miss any of my solutions. So that means that cos 2t is equal to 0. So that means that inverse cos of 0 is it's pi over 2, isn't it? Pi over 2. So that's my principal value. And then I can sketch the graph or use a cast diagram, and I will get 3 pi over 2, and I will get 5 pi over 2, and I will get 7 pi over 2. And if I wanted to continue, I'd go 9 pi over 2. But 9 pi over 2 is larger than 4 pi, so I don't need to worry about it. So final step, divide everything by 2. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, all the values of t at which we have a turning point, i.e. dy by dx is equal to 0. Okay, so remember, watching this does not mean you'll instantly be able to do it. You need to make sure you practice. The more you practice, the better you will become. And of course, amateurs call it genius, masters call it practice.